Welcome to Algebra 1 with Miss Betsy. I'm glad you're here today, and we are going to be discussing the Pythagorean theorem, which is a very cool application of some theory involving right triangles that helps us to be able to find distances. So we have a very real application of algebra in common everyday life, which makes you appreciate the fact that yeah, maybe I am really going to get something out of my studies in algebra after all that I can use. But first, there's a story here that I'd like to read you from my 365-day clean joke book. The customer wanted to buy a chicken and the butcher had only one in stock. He waited and said, "This one's a beauty. That'll be $4.25. "Oh, but that's not quite large enough," said the customer. So the butcher put the chicken back in the refrigerator, rolled it around on the ice several times, placed it back on the scale again. "This one is $5.50, he said, adding his thumb to the weight. "Man, that's great," said the customer. "I'll take both of them, please." So what's the moral of this story? Perfect example of my definition of what integrity is. Integrity is who you are when no one is watching you. So I'll give you some food for thought. Got a little bit of a silly story and something to chew on as well. If you're using the same text that I'm using, which is Algebra 1 for Christian schools, we are on page 418. It's chapter 10, section 6. It's the Pythagorean theorem. And they have a neat little story, interesting little story in here about the ancient Greek philosopher, mathematician Pythagoras, who together with his students developed what we call the Pythagorean theorem and how that came to be. And you might be interested in reading your text and finding that out. Of course, I know you always pore over your textbooks as it is and you devour every single word that's in there. But just in case you didn't look at it for a few days, read that story. It's pretty interesting. We have to have a little bit of a review before we can actually use our Pythagorean theorem. And you remember what a right angle is. A right angle is an angle that is exactly 90 degrees, and it's a square corner. When you have our Cartesian coordinate system that we use to graph linear equations, you have the x-axis and the y-axis are perpendicular to one another, and the angles that occur, that are made when you have two lines that are perpendicular to one another, those are all 90-degree angles. So they would all be right angles. And a right triangle, logically thinking, would be a triangle that contains one right angle. So this is what we call a right triangle, and you're always dealing with right triangles when you work with the Pythagorean theorem. And then one more definition, we have three sides of a triangle. And in a right triangle, we give those specific names. The side that is directly opposite the right angle is called the hypotenuse. Hypotenuse is how you can remember how to spell it, hypotenuse, but that's not how you pronounce it. See, hypotenuse, and that is the side that is directly opposite the right angle. And the other two legs or sides of the triangle have nothing particular. You have two legs of a triangle and the hypotenuse when it's a right triangle. And you're also going to have small letters that are assigned to the two legs of the triangle and to the hypotenuse of the triangle. So you have a right angle in the triangle. You therefore know that we have a right triangle. The hypotenuse is the longest leg, and we indicate that with a little c. The other two legs of the triangles are simply lowercase a and a lowercase b. Doesn't matter which one, because the only side The only one of those three sides of a right triangle that's important to know is the one that is directly opposite the right angle, which is called the hypotenuse, because what Pythagoras and his students determined that we now name after him, that's the Pythagorean, and it's not Pythagorean, Pythagorean theorem. And the Pythagorean a theorem is something that has been shown or demonstrated or proved to be always true. Theorems we haven't talked a lot about yet, but a theorem is something that has been proven to always be true. And what Pythagoras discovered, that when you have a right triangle, that the square of the hypotenuse is always equal to the sum of the squares of the sides, or the legs of the triangle. So we have our Pythagorean theorem. The sum of the squares of the sides of a right triangle equals the square of the hypotenuse. Now I know some of you are pretty frantically writing this definition down. Some of you are also just sort of yawning and saying, do I really have to write this definition down? No, you don't have to write the definition down, but you do have to understand what this definition is saying, and the more that you use it, the more you will, and the better that you understand it, the easier it will be for you to speak the definition of a Pythagorean theorem. What is this saying? The sum of the squares of the sides, a squared plus b squared, is equal to the square of the hypotenuse. That's all the Pythagorean theorem says. You take the length of the first side and you square it. You take the length of the second side and you square it. You add those two numbers together, you're always going to end up with the square of the hypotenuse. And this is something that we're going to use over and over and over in determining length and in determining distance. And you will hear reference to a 3, 4, 5 right triangle. And that's because it's the smallest right triangle that uses rational numbers for the lengths of the legs and the length of the hypotenuse. The hypotenuse is always the shortest distance here between these 2 points, because if we can walk around the corner, or we can cut across the grass. You know, when you see people walking through parking lots across grass and you see the path, what they're actually doing is they're doing their version of a bird's eye view, or as the crow flies, or making the third leg of a triangle, which is at the hypotenuse. What's our Pythagorean theorem say? It tells us if you take the squares of both legs of the triangle, add them together, you're going to get the square of the hypotenuse. So let's go ahead and see if this actually happens. Let's say that A is 3 squared is 3, and then we're going to square that if I can actually get my writing down correctly here. The second side is 4, so we're going to square that. And the hypotenuse is 5, and we're going to square that. And if our Pythagorean theorem is true, and it's a theorem, so it has been demonstrated to always be true, then 9 plus 16 had better be equal to 25. And of course, 25 is equal to 25. So the Pythagorean theorem is a true statement. Now let's go ahead and do a few examples of how we're going to use this Pythagorean theorem to find some lengths. First here we say, find the length of side B in the right triangle ABC. B, 12, and 15. So what you're going to want to do is draw the sketch. This says, find the length of side B in this right triangle. So what pieces of information are we going to have? Well, obviously, B is the length of the unknown side. What else do we have? How about C? About the other side of the triangle A is this bottom length, and C, which is the hypotenuse, that has a length of 15. Everybody agree that this looks pretty reasonable? And what does our Pythagorean theorem tell us? Well, it says a squared plus b squared is equal to c squared. 12 squared plus b squared is equal to 15 squared. It's nice to have your perfect squares and know what these are. 144 plus b squared is equal to 225. We're going to solve now. B squared is equal to 81. We subtracted 144 from both sides of this equation to end up with the expression here that tells us b squared is equal to 81. Now rather than keep on writing down here, let me go ahead and pull b squared is equal to 81 right up here at the top. Now do you remember what you do when you have a perfect square? When you have a square in your radical? What we've done, I can't believe I just said square and a radical. We have our variable for which we're solving is squared. Well, here we subtracted 144 from both sides of the equation because we used the inverse operation. Here the variable has been squared. What we're going to do now is take the inverse, apply the inverse operation of squaring, which is to take the square root. So we're going to say that the square root of b squared is equal to plus or minus the square root of 81. What's the square root of 81? It's 9. So you have b is equal to plus or minus 9. Now, why is that true? Well, it's because negative 9 times negative 9 is a positive 81, correct? But let's go back to this problem here. And what are we being asked? We're being asked to find the length of an unknown side. Is length ever going to be negative? No. So b, or the length of this unknown side, is 9 units. Maybe it's inches, maybe it's feet, maybe it's millimeters, maybe it's yards, maybe it's miles. but the length of this side is 9, and that's because we can figure this out, 9, 12, 15, because of that relationship that's been demonstrated to be true, where it says that if you have a right triangle, the sum of the squares of the sides is equal to the square of the hypotenuse. You'll use this all the time. Okay, let me do one more example here. We're going to do the hypotenuse of triangle ABC, 1, 2, and 3. And of course I promptly forgot which was which. 1, 2, and C. Question tells us find the length of the hypotenuse. Well, a squared plus b squared is equal to c squared. If you like to have the variable for which you're solving on the left-hand side of your equation, it's no problem. So we're just going to say c squared is equal to the sum of the squares of the sides. C squared is equal to 1 squared plus 2 squared. C squared is equal to 5. Okay, now you're thinking, all right, but what we just did, in order to apply the inverse of raising to a power, you have to take that same root. So we're now going to say square root of c squared is equal to plus or minus the square root of 5. So c is equal to plus or minus what? 5 is a prime number, so there is no perfect square. C is equal to plus or minus the square root of 5. Again, we're doing distance here, so we're not going to take that negative root. So the distance, or the length of that hypotenuse, is the square root of 5 units. And that may look really, really strange to you because we're not accustomed to having radical signs when we're taking measurements. Now, if you're actually doing a carpentry calculation or you're using Carpenter's calculator to find the slope of a roof or to figure out how to lay out your stairs, you're going to be plugging these in and they're going to give you a fractional representation of what the square root of 5 is. But for actual calculations where you're not reducing it, you're just going to go ahead and leave the length of this hypotenuse as being the square root of 5. So this is how, using the Pythagorean theorem, we end up with having radical symbols that represent length, because there are very few right triangles where everything works out perfectly like we did, where we had the 3, 4, 5 right triangle, we had the 12, 14, 15 right triangle. Most of the time your right triangles are not going to be perfect squares, so you end up with radical symbols in your answer, and that's okay. That's what it's supposed to be. Enjoy playing with these, and I'll see you next time.